Hello guys, welcome to the channel. I hope you all guys are fine and doing great. Today we are going to discuss this delete node in a doubly linked list problem. Like it's basically we are given a doubly linked list. Doubly linked list is basically a list where a node have two pointers next and previous. Like in simple linked list, I have this kind of linked list. This point to this, but in doubly I have a previous pointer that point to its previous. So we are given a variable x. We have given a variable x and we need to delete the x node, and we are given one base indexing, like this is node 1 2 3. Okay, so we have to delete x node. Okay guys, so here how we gonna do it? See, suppose we have like something like this, a simple way to solve it. Otherwise we need to take care of some cases, and what are those cases, why I choose this approach, I will gonna explain after explaining my approach. Okay, suppose this is my linked list. Suppose this one, I need to delete this particular node. Okay, so what does basically happens, these two things, its next pointer should point to this, its previous pointer should point to this. Okay guys, these two things should have taken place. Okay, so how to do this particular thing? This is the node I want to delete. So basically what I am doing, I am taking two variable, previous and t. This previous is my this node, this node previous is the previous is the node that I want to delete. Previous, this is my previous node that I want to delete. This is my t node. Okay, so after reaching at the node I want to delete, what I will just simply do, I will make, this is my previous node. Now what is the previous node of previous node? This is previous. Okay, take it like this. Suppose this is not this is x. Suppose this is not previous. This is variable x. Suppose for a minute, variable x or y. This is node y. So previous node of y is this. So what I am doing, y previous and in next of this particular node. This is my y node. This is all about how we visualize the linked list. Y node, this is my previous node, previous node of y, this particular part. This is next portion. I will gonna put t in it. I will gonna put t in it. So this will gonna represent t. Okay guys, and you will not believe, but I don't take care of this particular thing. I just remind this thing when I am recording the video. I did not write anything for this particular h, but still I am getting AC. Okay, so let me tell you how I will go to this now, how I will set this particular age as well. Now for this edge, what I will do, in my t previous, in my t previous I will put, basically in my t previous, for this t previous, this node, but I will simply, let me change the color, I will simply put previous of previous. I will simply put previous of y, previous of y. This is my t node. In the previous, this particular node, t previous, I will put y previous, means this particular node. So my t will point to this node. Okay, so let me erase this particular thing for now. So here you can see, okay, one edge case I am taken. If my x is 1, then I will simply return head next. I will simply return head next. I will delete this. This is the next node I have. Otherwise I will take t and previous and run my loop till x time. So my t is this, previous is this. I will just make, okay, this y is previous, this is y, and this is my normally previous node, this is this previous pointer, y previous next I will gonna put t, and I should write this particular for this particular node as well, but it give me AC, so I just skip it. Okay, this is a page marker extension I use, and let me submit it again. Linked list is all about how we are visualizing the things. Okay, we are all the test case pass out, and for previous edge, what I need to do, t previous edge of t should be equal to, okay, I need to check if t exists. Why I choose it? Suppose if my t does not exist, if my t does not exist, why I take previous? Like suppose I take only single variable t and maintain according to this, but if my t does not exist, so I need to write a separate case for the doubly like this. So in this approach I don't need to do it, but I just need to take it if my t exists. T exists means this is not the last node that I need to delete, because if it is the last node, then I don't need to update the previous pointer. I don't need to update the previous pointer. So what I will do, if my T exists means T previous will be previous of previous. Its previous is y node in my figure. So you can see this thing. Like you can see, this is for the next node. This is for the previous node. Okay, all case are easy. So I hope you guys understand the problem. If you have any doubt, you can just comment out. I will gonna explain you. Guys, please subscribe the channel and like my video for giving me motivation to create more these type of videos. So please subscribe the channel, guys, and thank you for watching this, guys. Stay tuned.